Hey everybody, this is Mr. Storm, and today we're going to create a totally original, completely new, never been done before game called Flappy Fish. It might sound like a game that already exists, but this is a game about a fish. See, he's a fish. He has all the things the fish have. He has wings and a beak and feathers, and so that's, in my mind, completely fish-like. Okay, so we're going to create this game. This is essentially an endless runner game, but in order to make it an endless runner, we'd have to do a lot more code. So I just put an end to the level. This is not going to be a full game. This is really just going to be this level here. We're going to implement the functionality and have the level just be done. And then once it hits this, we'll just restart the level. So it will be a fully playable game, but it's not going to be very fun. There's going to be no menus or no saving your game, no extra levels, nothing like that. All right, let's hit play and see what the game looks like currently. And nothing. He just falls to the ground and he flaps his wings. Now, this wing flapping animation, it's already built in there for you. I put it together. The animations are in the animations folder if you want to take a look. But it's already in there. So at this point, we have a fully functional game, a game that we can actually start programming. So the first thing we want to do is we want to get this bird moving around. We want him to actually always move to the right, and we want to be able to hit the space bar to make him fly up a little bit, right? That's really all we need to implement for this bird. So let's create a new script. I'll create a new folder, and I'll name this scripts. There we go. And inside the scripts folder, I will create a C# script, and I will call it bird. Pretty easy. And I'm going to drop my bird script onto, oh, why did I name it bird? This isn't a game about birds? Get out of here. Oh man, I'm going to delete this. We can't have it called bird because there are no birds in this game. It's a game about fish. That's taken a long time. All right, there we go. Let's create a C# script. I'm going to name it fish, huh? Because it's about a fish. All right. And then I will drop my fish script onto my fish character here, my fish object. Ooh, this is taking quite a bit of time. All right, there we go. And let's double check just to make sure my script is actually attached. Beautiful. All right, I'm going to open her up in VS Code. And it opened up on my other screen here. So let's let it load and I'll bring it back over. Okay. Beautiful, beautiful, beautiful. I'm going to fix these brackets here because I actually don't want the brackets to be like this because I like them like that. All right, perfect. Beautiful. All right, so we've done movement scripts before. This is actually going to be easier than a lot of the movement scripts we've made because there's not a lot of complex movement for this script. What we do need is, obviously, we need a public float speed equals 1. Actually, we'll make it 2. Let's see what's going on with these errors here. Okay, what's the problem? Weird. Let me save this. Huh, all right, well, it still works. Okay. Let's open up our fish script again and see if it fixed itself or if it's not mad at me anymore. That was weird. All right, let's see what happens. Everything good? We good? We're not mad at each other? Okay, perfect. It's probably going to get mad at me. All right. So we have a speed, public float speed, and it's set to 2. That's what we want. Let's add a force as well. Instead of a jump force, this is just going to be force, but it's going to be basically the same thing, so we'll just call it force. Equals, and we'll set it to, say, 300. Perfect. All right. Okay. Now we need to get a reference to our rigid body, and we'll actually get component. No, not get component in parent, just get component. And we'll say rigid body 2D, and we'll set the velocity equal to vector 2.right. And hopefully at this point you can basically finish this line of code on your own. Times speed. So this is going to make it actually move to the right constantly, which is what we want. Now the last thing we need to do is implement our force. We're going to do it in the update method, and we'll just say if input dot get key down key code dot space. So if we press the space bar, then we want to get component rigid body 2D. And I want to add force. We've used this before. Vector 2.up. So I want it to go up times force. Pretty easy, right? That's basically our entire movement script. The only thing we need to do here, the only thing we have left to do here is to make it reset the level every time we hit literally anything else in the level. Because if you come back here, if you look, if we hit the ground, we want to restart. If we hit an obstacle, we want to restart. And that's really the only other objects that exist in this game are the ground and the obstacles. So if I hit anything, I want to restart the game. So inside my update, actually, you know what? I'm going to call this I'm going to create a void on collision enter 2D. We'll do this as a collision method, and we'll say collision 2D other. Now inside this method we need to call scene manager, but I need to declare the library up here using Unity engine dot scene management. We've done that before. We know how that goes. And then in here, I'm going to call scene manager dot load scene. And what is the name of my scene? Main. Okay. Main. Pretty easy. And believe it or not, that's really our entire fish script. That is the entire script to handle how our fish moves. So let's go ahead and save this, and we'll go back to Unity. I'm going to check my fish here, make sure it has its script on him, and we have our public variable. Beautiful. Let's go ahead and play our game. Let's play our game. There we go. Almost. Come on. I believe in you, computer. Oh gosh. All right, now he's dying a lot. Okay, so that's good. As long as he hits the ground, the game restarts. So let's try to. Ooh, I can swim. That's beautiful. And he goes off the screen because the camera's not following him. Uh-oh. I ran into an obstacle there and it restarts. That's exactly what we want. Okay, beautiful. So at this point, our movement is completely taken care of. We want to fix that problem with the camera. So we can write a very quick script for that. And this is actually going to be a super, super easy script. We've done variations of these camera follow scripts before. And this one is going to be really no difference. It's pretty easy to do. Let's call this camera faux. Why not? I don't feel like typing out the whole thing. And I will attach this to the main camera before we open it. Come on, hello, hi. Can we attach things now, please? Thank you. Beautiful. Okay. There we go. And my camera faux script is attached to it. All right. Open this guy up. Okay, pretty easy stuff. I'm not going to need a start. Let's fix my brackets here. I don't need this comment. I know what update does. All right. Now, one thing we need to do is we need to get a reference to the game object that we want to follow. That's pretty easy to do. We just public transform target. Now we're using the transform of this target because we're just trying to track its X. We don't really need to track the actual game object, just its X position, because we're going to keep everything else the same. All right, and then inside of update, what we can do is transform.position equals, so we're saying the transform position of the camera itself equals a new vector 3, and it's going to be a vector 3 because it's an object that exists in 3D space, cameras are. And we're going to set our X value equal to the target.position.x. And then the Y value is going to be transform.position.y. And the Z value is transform.position.z. That's it. That's pretty much the entire camera follow script. Pretty easy stuff. Let's save this and test that out. Make sure we didn't screw anything up. Real quick before I move on, I just want to clarify again. We're only tracking the X. So as our character moves to the right, the camera should follow, but it won't go up or down, and it won't go in and out, because these are just going to be our transform.position, which is the position of the camera. So it's just going to keep its own Y value, keep its own Z value, but change its X based on the target that we're following. Okay, good. All right, and let's go to our main camera. Let it update. Come on. There we go. Now, if we played the game right now, the camera actually wouldn't follow because we have to identify which target we're following. And we are going to follow the fish target. So we're going to click there and just drag that right over. Now, if we play the game, it should work. Come on. Okay, and look, the camera is following it perfectly well, right? We're able to play and, oh, I hit an obstacle. But yeah, this is exactly what we want. And again, you can speed up the game if you want, because we set the speed as a public variable. You can set the flappiness of the fish, because that's a public variable. Okay, so this game's basically done. The only thing we want to do is we want to make these obstacles a bit more dynamic. They don't really do anything. They just kind of stay there, and it makes the game super easy. I want these to move up and down. And so we can write a very easy script just to make that happen. And let's see, is there anything I need? Nah, we can just go into it. Let's write the script. So I'm going to go create C#, and I'm going to call this walls. Alrighty. And my walls script is going to be added to all of my walls at the same time. Let's do, I'm going to select all of these. This is a handy little trick in Unity. If you select all of the objects in a category, or just like this with the shift click, you can grab a script, drop it over there, and it will add it to all of them. So now we have the wall script on every single one of our walls. Perfect. All right. So now we have a wall script attached to all of our walls. I'm going to open it up in VS Code. Okay. Fix my brackets. Okay, perfect. All right, so I guess the first thing we need to do is we need to set a speed for how fast the walls are going to move, right? Speed, set that equal to 0. because I want by default my walls not to move, and then each individual wall we can set its speed differently. Okay, and then here it's just the same thing. Get component rigid body 2D dot velocity equals vector 2 dot up times speed. So now this will move up as soon as the script starts. It'll move up at the speed. And then, ooh, we can use something new here. We've never done this before. So we're going to create something new. First of all, let's get rid of this update method because we're not actually going to need it. What we want to do is we want to create a new method called, let's see, let's call it reverse. Sure. Reverse. Did I spell reverse correctly? I don't know. R-E-V-E-R-S-E. All right. We'll just pretend that that's okay. And all we want to do is we want to repeat this statement from up here. Actually, we'll just take this here and put it down here. And instead of vector2 dot up, we can just set velocity times equals -1. Because it's going to change our velocity to a negative value or to a positive value depending on the reverse. Now, last time, or if you remember all the way back to the rat race project, we used this same thing so that we could have the rats, as soon as they collided with a wall, they would turn around and go backward. This, we want it to go back at a specific interval of time, which is going to be a little bit tricky. We've got to do something new. We're going to use a new method called invoke repeating. This will basically invoke or call a method at a specific interval for the duration of the game, right? And the method that we're going to invoke is our reverse method that we just created. And I want 0 there, and I want it to be, oh, we haven't set an interval for how long I wanted. So we need a public float. We'll call this switch time. And we'll set it to 2. Yeah, that works. Basically, we want it to switch time. So what this method is actually, or what this method call is doing, what do you mean? Oh, I spelled repeating wrong. All right, so what this invoke repeating method is doing, if I hover over it, is it's going to invoke the method in a certain amount of seconds and then repeatedly call that over and over again every time. So if you look at the way the method is structured, we have invoke repeating string method name, so the method name as a string value. And then that center piece of information is the time. And that time is how much I want to wait before I call my first iteration of invoke repeating. And for us, we don't want to wait. We just want it to happen right away. So we're going to set it to 0. And then our float of repeat rate. How much are we going to repeat this? Or how long time are we going to wait until it repeats? Anyway, we're good there. That's pretty easy, right? Nothing crazy here. And again, nothing too new. Let's go ahead and save all of this and go back to my project. And now if I go to each of my walls here, I can see that I have this, I'll give it a minute. Take a sip of my soda while I'm waiting. I can see that I have 2 public variables that I can change, a speed and a switch time. So if I just leave this at speed 0, then this wall won't move at all. But if I go to this one, I can change this to a speed of 1 with a switch time of 2. Let's see what that actually does for us in the game itself. Okay, so that wall's stationary. And this one, oh, look at it. It's moving up and down. So it adds some more dynamic stuff to the level. Perfect. And again, I can do this for all of my obstacles. I can make my obstacles move move up and down at different speeds with a different switch time. That's going to be weird. I can do all kinds of stuff. I can have some that are kind of opposite each other at the same speed and switch time, so it makes like a gap that keeps going up and down. Yeah, I can make all this stuff. So what I want you to do, in the last term, I had you turning in all of your scripts, and that was all you needed to turn in. In this term, I want you to turn in your full projects, because we're going to be doing a lot more in each of these games, and I want to see your specific version of these projects. So I'm very quickly, I'm already at 20 minutes, but I very quickly am going to show you how to turn in your assignments for this project. So once you're done setting all these obstacles to different speeds and switch times so that it makes it a little bit, obviously don't mess with the 2 at the end there. But once we're done getting this level set up the way you want it to be set up, then what you need to do is go over to File, and first of all, we need to save everything. So save scenes, save project. And then we go to File, Build Settings. And the Build Settings is basically this menu here. Now this menu is going to show you which platforms you can build games for in Unity. So let's say I wanted to build this for iOS or for my Xbox One or for Facebook or whatever I wanted to build this game for. I would have to have the SDKs for all of these projects. So if I wanted to build for Xbox One, I'd have to have the Xbox One XDK or SDK and basically the module, the developer's module, which I'd have to go download from Microsoft. But I don't have that installed on my computer. What I do have, though, is PC, Mac, and Linux standalone. That comes default with Unity. So I can build this game for PC. And so what I'm going to do is I'm going to make sure PC, Mac, and Linux standalone is selected. In my Scenes and Build menu here, I want to make sure that I add my open scenes, which is my main scene. I only have one scene in this game, so it's my main scene. My target platform I can keep by itself. I don't have to change that. It's going to go to Windows. It's going to go to 64-bit Windows. If I go to player settings here, it'll open up this menu in here. I can change my company name, the name of the products. Let's make this bigger. I can change the default icon for the game, which sure, I'll go ahead and do that. Why not? Let's change it to, oh, that's gross. Nah, I don't want to do that. Let's just go back to, yeah, we'll go back to none. I can change my default icon. I can change the cursor in the game. All kinds of stuff. This is the menu that I really want you to pay attention to, resolution and presentation. We want to set the default is full screen to off. We do not want it to default to full screen. And we want to enable this resolution dialog because it allows you to choose between full screen or windowed whenever you fire up the game. And that's what we want. Okay, I'm going to click build and run. And it's going to take a minute. Oh, actually first, it's going to ask me where I want to put my stuff. Now, naturally, it's going to want to try to put it in this folder. And that's a good idea. But what I want to do first is I want to create a new folder. And I want to call this build. Right? I'm going to create a build folder because this is going to be my build, my first build of this game. Flappy Fish. .exe. I'm going to make sure that my build goes into my build folder. Click save. And it's going to take a minute. It's going to actually build my project. What it's doing is it's packaging the entire project together. It's creating the executable file. It's putting all the data files together where they need to go, and it's actually building my full project. And when it's done, we will play the game, see what it looks like when it plays on Windows. Now, hopefully this project wasn't too difficult. The next couple of projects are going to be way more advanced. We're going to get into, building a full game with front-end splash screen and menus and full levels and stuff like that. All right. So this is my Flappy Fish game. This is the dialog window that opens up. I want to uncheck windowed because I want to check windowed because I want it to be a window. I don't want it to be full screen. I can set which display I want it to display on, the graphics quality and whatnot, all that stuff. I can even go to the input tab and see what the controls are. I'm going to hit play. And it's going to pull up my game in this window. And I can play it. It is a full-on application on my computer. I can give somebody this application and they can play my game on their home computer. This is beautiful. All right. Let's take a look at the files really quickly just because I want to, let's go back here. Let's go games. Sorry, I'm trying to find and there we go, Flappy Fish. All right, so this is my Flappy Fish project folder. Now, what I want you to do to turn in this project, you remember that build folder that we put together before? That has all the stuff in it that you need in order to play the game. What I want you to do is right-click on the build folder and click Send to Compressed Zipped Folder. And it's going to create this build zip file. I want you to turn in the build zip file. I don't need your entire project. I don't need all of this. I just need the build, because what I'm going to do is I'm going to open up your project. I'm going to play your game. And if I can play your game without any errors, if everything works, if it all looks good, then you get full credit, right? So I'm looking for specific functionality, and I'm going to be testing that by playing your game. So I just need the build folder zipped together. All right, hopefully that's not too confusing. I can't wait to see what cool configurations you come up with. Oh, I forgot to say, you are allowed to move these around, by the way. If you don't like the way they're set up, you can move the walls around. You just have to click on it and you can just drag them wherever you want. So it's up to you. You can put the walls wherever you want. All right, I've been yapping long enough. I'm going to shut up and I'm going to let you get started on this first project of fourth term. Please, please, please don't hesitate to ask any questions you have. I tried to start with an easy project because it's going to get a little bit crazy in the next couple projects. So hopefully you have fun with this one and we will do some cool stuff next time. Thank you very much for paying attention. I'll see you next time.